So this is part 3 of inexact differential equations. Once again we are going to see the solution of the inexact differential equation, and this is the example which has been given. So in this particular example, what we can do is we can write the equation in this form: x square y square, right? So x cube y cube it is. So I am going to take the x outside and write like this: dy plus, from the other term, from the second term, I will be taking y outside, so I will write x square y square minus 1 into y dx is equal to 0. Now doing a slight rearrangement so that the equation will look in the form m dx plus n dy is equal to 0. I will just write this as x square y square minus 1 y dx plus x square y square plus 1 x dy is equal to 0. So now this looks in the form m dx plus n dy is equal to 0. But this is the type of equation which, like was discussed in part 1 of this particular inexact differential equation series. So once again I am giving the link to that video in the description box. Again, you are advised to look at it so that you can revise the rules for finding out the integrating factor. So in one of the rules it was given to you that if your equation can be written in this form, which form? f1xy y dx plus f2xy x dy is equal to 0. If the equation can be written in this form, then the integrating factor of such an equation is given by 1 upon mx minus ny, provided of course that mx minus ny should not be equal to 0. So in this case we are seeing that the given equation can be written in that form. So this can be treated like f1xy y dx plus this is treated like f2xy x dy is equal to 0. And so this is the integrating factor. So we will find this integrating factor. Now over here the value of m is multiplying this thing, this y term inside, x square y cube minus y, and then n is given by x cube y square plus x. So we will just find the value of mx minus ny. So mx minus ny is equal to, now multiplying m by x, so that gives us x cube y cube minus xy, now minus ny, so minus multiplying this by y, minus x cube y cube, right, and minus xy. So these two terms get cancelled and we are left with minus 2xy, which is not equal to 0. So the integrating factor in this case is given by 1 upon minus 2xy. So this is the integrating factor. Now we have to multiply this integrating factor with the original equation which is given to us, right? So over here we had rewritten the equation in that form which we needed. So we will just multiply this equation with this integrating factor which we have found out. So integrating factor is 1 upon minus 2xy. So we are going to multiply, or rather divide, by minus 2xy. So I will write this as x square y square minus 1 into y divided by minus 2xy dx plus x square y square plus 1 divided by minus 2xy dy is equal to 0. So our equation is now going to be written as implies, into bracket I'll just write it, minus x y square divided by 2 by cancelling out the common terms, plus 1 upon 2x dx, and again the same procedure for the next term, cancelling out the common terms, minus x square. Remember, over here x has been multiplied, so this is actually x cube. So minus x square y divided by 2 minus 1 upon 2y dy is equal to 0. So this is what we get after dividing the equation by minus 2xy. And now we are going to first just check whether this equation is exact or not, and then we are going to solve it again by using the method of exact differential equations. So over here this is m and this is n. So dou m by dou y, in this case again we are treating x as a constant, only we are differentiating with respect to y. So this comes out to be minus xy, minus 2xy divided by 2, so that is minus xy. Same thing for n, we are going to partially differentiate with respect to only x. So therefore over here this one will be constant, so derivative will be 0. Only this term is being differentiated partially with respect to x. So minus 2xy divided by 2, and that comes out again to be minus xy. So therefore dou m by dou y is equal to dou n by dou x. So both these are equal, so the condition for exactness is satisfied. Now we will solve the equation by using the method for exact differential equations. So you are going to integrate this term, integration minus xy square divided by 2 plus 1 upon 2x, integration is with respect to x, plus terms in n free from x. So there is one term, and that is minus 1 upon 2y dy is equal to c. So now we will see what is the solution of this particular integration. So once again I will just write over here what we are doing. Integration of minus x y square divided by 2 dx plus integration of 1 upon 2x dx and minus integration 1 upon 2y dy is equal to c. So this integration will be, now integration is with respect to x, so minus x square y square divided by 4. This is integration of x is of course x square y divided by 2, so we get minus x square y square divided by 4 plus we are getting over here half log x minus half log y is equal to c. So after integrating, this is what we have got. Now once again, if you want, you can again simplify the expressions. So how we are going to simplify the expressions? You can take common whatever is the denominator. So we can just write minus x square y square divided by 4 plus half. Now this is log x minus log y, so that is going to be log of x upon y is equal to c. So further on, if you want to simplify, you can simplify, or you can even leave the answer in this particular form. Usually it is a good practice to just simplify the given answers so that the answer looks to be in a more presentable form. So there are some things that can be done over here also. For example, if we are not happy that we have minus over here, so we can take the minus sign outside. That means what we can do, we can write like this: minus x square y square divided by 4, right? And if we choose to treat this minus sign outside, then we can write like this: minus half log of x upon y is equal to c. Then what you can do is transfer this negative sign to the right hand side. So minus c is still c, that means it's still a constant. So you can write this as x square y square divided by 4 minus, now if you are not happy with this minus, you can make it like this: 1/2 log y by x is equal to c. If you want to further simplify, then one more step also you can do. You can just write this as x square y square divided by 2. That means I am taking 2 common and shifting the 2 to the right hand side, and once again, like I said, 2c is again c, it's a constant. So x square y square plus log y by x is equal to c. And now of course further simplifications need not be done. You can present this as your final answer. So x square y square divided by 2 plus log y by x is equal to c. Thank you.